Welcome everybody to this presentation. As Jarem already mentioned, my name is Arjan van Proosdij. I'm a solutions manager for CloudPoint at Veritas. For the people that don't know Veritas, Veritas is an information management company, and our software and our solutions enable organizations globally to harness the power of their information. And you may know us maybe from NetBackup, a leading data protection solution in the enterprise. Now, the objective of today's webcast is really to showcase you a new addition to our data protection portfolio, and it's called Veritas CloudPoint. And we would like to show you the capabilities that new product has in protecting your Oracle environments in the cloud. And on this occasion, we have picked Amazon Web Services as the testing ground for this demonstration. So what we want to do is really to start talking first about, in a couple of slides, about to provide some context about Oracle databases in AWS and kind of the common ways of how you can back up those databases today. And then we have Sucintya, as Jarem mentioned already. He will do a demonstration, a live demonstration on how CloudPoint is backing up and recovering your Oracle databases. And everybody hopefully can see my screen. I forgot to check that.
I see it, and I see no warning messages from anyone that we don't see anything.
Fantastic.
So we should be fine.
Let's crack on with housekeeping. So for the people that are on Twitter and would like to continue the conversation with us, I would like to ask you to use the hashtag #TransformYourBiz. So that will allow us really to pick up very quickly your tweet and to interact with you. Also, at the end of the presentation, I will have a free download link for you where you can download CloudPoint and you can then you evaluate the software in your own environment. And also, let's interact. I know that Jarem already mentioned it earlier, but you will have a question and answer widget on the right of your screen. I really encourage you to use that capability to when we are in a presentation and a question is popping up, quickly put that in that question and answer panel, so we can pick that up at the end of the presentation where we have some time left to take your question and hopefully answer that question for you. So, what I want you to walk away with later on after this presentation are three important things. So what I want you to be walking away with is that you know whose responsibility is of backing up your data in a cloud environment. And also I would like you to understand what kind of the shortfalls are of the common traditional backup options that are currently used in the cloud, and that's why you should start looking at a backup approach that has been built right for the clouds. But with that, I think it's now time to start building some context around what we are going to do. So what we see is that enterprises are at various stages of an ongoing digital transformation, and they're leveraging cloud infrastructure as a service, often as the primary component of this journey. Now, in fact, our Truth in Cloud survey that we concluded earlier of the end of last year, that revealed that 56% of enterprises operate with a cloud-first mentality when it comes to deploying new applications, new workloads. And 67% of those organizations use 2 or more infrastructure as a service clouds today, with the average being around 3 clouds. Now, what we're also seeing is that spending is on the rise. So with enterprises now expecting to spend on average just over 18% of their IT budgets on cloud technologies by 2019, which is a 56% increase from today. So that's quite a significant jump there. But while cloud opens endless opportunities for those enterprises, it also introduces some of those challenges, especially when it comes to data protection. The common misconception is that data protection is already built into the cloud, and it is when it comes to security or durability of the platform. But when it comes to backup and recovery, it's not included. And this puts 51% of enterprises that we surveyed during that survey at risk, as they really believe that it's the responsibility of their cloud provider to back up their applications and the data that they are storing and running in the cloud platform. Now, if I show you this, I'm sure you will agree with me. This is a clause from a major cloud service provider, and we took that from their online customer agreement. And it really clearly shows that we, as the users, are responsible for backup of our content in the cloud. It clearly states that you are responsible for taking your own steps to maintain appropriate protection and backup of your content, and also routinely archiving your content. So that security and that durability that is already built into that cloud platform, it can't be a substitute for backup, and that's what we're trying to message for the last year really into the market. Now, the enterprises that do make backups, they use a variety of approaches. Some use a backup solution that's provided by their cloud provider. Others use homegrown cloud-native tools, or use a third-party solution, or try to retrofit the same solution as they are using in the data center. Now, what we believe, all those options may work, but we believe that it simply won't work on the long run for cloud. For example, when you look at the backup tools that are provided by a cloud provider, they may prove very easy to add on to your cloud account, but they can also lock you in very quickly with proprietary backup formats, which can't be replicated elsewhere quite easily. For example, homegrown backup scripts, they may provide for a free basic tool, but these are really hard work in a dynamic cloud environment. In a cloud environment, you will see virtual instances being launched and terminated all the time. So what you need to do is really maintain those backup scripts to reflect all those changes constantly. When you look at legacy backup, often they are claiming cloud support, but key functions and application support are often missing or still unproven. And also legacy backup, to be honest, has never been really built for cloud environments, and they may prove very complex to run, which also can escalate your total cost of ownership. Now, if you then also take into account what I said earlier about the fact that enterprise is using now on average 3 different clouds, you can kind of conclude that they will also use 3 different backup approaches for each cloud, which really drives up that data protection fragmentation with all the risks and complexities and cost implications that can come with that. Now, let's now have a look at what options you have if you want to move your Oracle databases to AWS. Oracle is widely used in AWS Cloud. Oracle is offered via RDS, via the RDS service, which stands for Relational Database Services. But many AWS users also run Oracle on EC2 instances, so that's the virtual machine that are running in the AWS Cloud. Now, RDS is kind of recommended way of running your Oracle database, as AWS takes care of most of the tasks that are involved in operating your Oracle database in the cloud environment. From deployment, from the management to maintenance, to even basic backup functions. And so you can really focus on tuning and also optimizing your applications in the AWS cloud. But if you need more control or additional features, then you should go for an Oracle database on an EC2 instance. That's kind of the way to go then. That will give you all the flexibility and control you need in your database environments. So yeah, Amazon RDS, they offer an automated backup function that is already part of the solution, or you can use a manual snapshot feature. What RDS is doing, it creates a storage volume snapshot of your database instance, so backing up the entire database instance and not only just the individual database. So that's an advantage. And then the snapshot is stored into S3. S3 is the Amazon object storage platform, which then replicates it to at least another availability zone within that same region. So the only thing what you really need to do to enable the backup feature within RDS is picking your backup window and setting the backup retention period. I think the default period is 1 day. But you can set it up to 35 days, I believe. And then you you can pick the backup window, which is a 30-minute window within an 8-hour block. So you pick your own time that suits your application. I think what you need to be aware of, and maybe for some is a drawback, is that, for example, when you delete or disable your database instance in RDS, you will also lose your automated backups that you have been making. This is not the case when you made a manual backup. So, for example, if you want to delete or disable a database instance, it is recommended first to take a manual snapshot of your instance and then delete it. Then you always have that snapshot available to recover from and launch a new database application. Also, when it comes to restore, a restore will create a new database instance, so not a storage volume. So a storage volume that will be easy to mount again to the existing database instance. That's not possible. So what RDS is doing is really launching a new RDS instance. So that's some of the pros and cons of using RDS. Now, when you are running Oracle on an EC2 instance, of course, you have many more options available for backup. You can think about switching your log files, or creating checkpoints, or whatever we have. But since those snapshots already create a point-in-time image of your disk, I believe there is not really any need for all these options. If the backup image is kind of the exact image of the original server at a consistent and well-defined point in time, it should really work for you. So basically, all what we need to do is put the Oracle into a backup mode before we taking the snapshots and then releasing it later on. So I can quickly walk through the steps to show you how you could take a manual snapshot of your Oracle database in AWS. Now, first of all, step one, we need to put the database into backup mode. That means that we can take a copy of the data without shutting it down. And also, we don't taking the database offline for the users. And then step two, and then we're ready to snapshot the volume. So this saves kind of the data in the volume at the point in time that we issued the snapshot command. And because the database is now in backup mode, we can do this. But in step three, we need to make sure that we monitor the snapshot. We need to make sure it reached at least some progress. So because then we know that the snapshot has taken the bitmap of the image of the blocks, and also that means that the snapshot is secured. So, but once that is done, we're ending up at step 4, where we can put the database back online again. Back in backup mode again. And the snapshot then will continue to create in the background. And also, it can take up to a few minutes or maybe a little bit longer, depends on the size of the volume that we try to snapshot. Once we've done that, we have to archive the current redo log. And then we need to take a snapshot of the flash recovery area. This step makes it really make sure that we can complete. We get a kind of a complete set of recoverable files if we need to recover them. So if we need to recover the database from the files on the data volume, we will need the FRA really to roll forward the transactions that already occurred while we were taking the backup. Now, if you look at this approach, it works, but hopefully you agree that there are a lot of steps that we have to go through. And if you're not familiar with AWS and the Amazon command line or the interface, that could kind of be quite cumbersome to work with, and especially when you start looking at much larger Oracle environments, this can become quite complex. Now, these are some of the limitations that Amazon RDS Snapshots deliver us. So, for example, there is no application awareness. So, for example, when you look at an application server or a database server, there is always some memory cached in the memory, and an RDS snapshot is not automatically flushing your application, so that data won't be captured if you do the snapshot. So that's something we need to do manually. Then, for example, there is no built-in scheduling or retention feature that is automating your whole scheduling and snapshotting. It's something you can do. You can use CloudWatch as kind of an event manager, and then use cron extensions to make sure that you can do a snapshot at a certain time. But again, that's kind of a workaround. It's not something that is easy to be done within a couple of clicks. And then, if you look at, for example, the snapshotting of the recovery capabilities, EBS is not really caring about what's in the snapshot. So it doesn't know what's in the snapshot. So this makes it really impossible to find and also access individual files directly and recover that from the EBS snapshot. So consequently, you cannot perform a granular recovery directly from EBS snapshots. And also, restoring data from the snapshot creates a new EBS volume, and that's kind of an advantage, because that EBS volume you can then do whatever you want with it. So you can mount it to a new instance or to your existing instance. I think that kind of works well. But what I believe, if you look at those two solutions we just talked about, so we got the basic backup features that we have in RDS, or the manual snapshotting capabilities that I picked in this case for the build your own kind of Oracle database on Amazon. It's quite of cumbersome to work with, and I think what you really want to do is using a solution that is really built right for cloud. It's kind of doing all the things I just talked about, but makes it much easier for you. And that's where Veritas CloudPoint is coming in. So what CloudPoint is doing, it really taps into the native snapshotting capabilities that already exist in the cloud. But it also gives you kind of a single dashboard to efficiently manage and orchestrate all the backup and recovery operations across not only the AWS cloud, but across multiple clouds, all from the same place. So what you get is an intuitive dashboard, and Sucinta will soon demonstrate you the dashboard and walk through it. But really, the dashboard enables backup and recovery management and orchestrations across all your applications and data in Microsoft Azure, in AWS, as you just mentioned, and in the Google platform, as well as in your data center. And it's done all from the same place. Now, what you also get, and that's very, very interesting, is the role-based access controls. This really enables you to define access controls and also delegate permissions for an individual user or group of users, really to enable self-service backup and recovery. For example, when you are a backup administrator, you can now easily provide an Oracle DBA with controlled access to his or her databases to perform backup and recovery operations independently, so you don't have to involve the backup administrator. And the backup administrator doesn't have to grant access to all the capabilities and all the environments that are managed with CloudPoint. So I showed you the single dashboard, which really allows everybody in the organization to manage backup and recovery jobs across different clouds. But how does CloudPoint now work? Now, You can very easily deploy CloudPoint direct from a cloud service provider's marketplace. So we currently are in Azure and in the Google Cloud Marketplace, and very soon we also will be deployable directly from the AWS Marketplace. But in the meantime, if you want to deploy it in AWS, you can download the freemium software from our .com site. So once you have installed CloudPoint, what CloudPoint is doing then is automatically discovering all your assets that are in that cloud form, in the cloud platform, but also in the cloud platforms that you have plugged into the interface. And also it will capture all the snapshots that you may have been taken prior you installed the CloudPoint software. And then once you have that, you will get a big long list of all the assets that are basically in your cloud environments. And what you can do then is allocate policies that you can define for those workloads. And over time, we also will have name tagging. So then CloudPoint will be able to automatically protect your instances or assets as soon as they launch. Now, and then for the cloud instances that run Microsoft SQL, Oracle, or Amazon RDS, Aurora, or MongoDB, CloudPoint will make an application-consistent snapshot without having to install any agents on that. So it's an agentless approach. And in each snapshot, again, will be indexed, which allows for all kinds of intelligent features, such as quick granular search and granular recovery down to the file level, but also classification of the snapshot and for example, identify personally identifiable information, something that's quite hot item at the moment with the GDPR coming up later in May. And finally, you can also then automatically replicate your snapshots to another region simply by applying the right backup policy. So in summary, if you look at CloudPoint, it uses the snapshotting technology that's already exists in the cloud, but it's really adding on all those crucial enterprise data protection features that IT teams require in the cloud. Now, here's a quick summary of all those features that we added in the latest release, and Sushintya is going to talk to you and show you in his demonstration these features. So Sushintya, I hope you have your demo environment ready, because I would like to hand over control to you.
Absolutely, sounds good. Thanks, Aryan, for the introduction. I will switch over and see if I can share let's start with sharing my webcam so people can see me.
Hey,
okay,
hi.
And I also need to share my screen. I am a little... Can you help me there?
Did you see a pop-up? Aryan should give you the control. Did you give the control, Aryan?
Not yet. I'm just trying to find out how to do that.
I can do it.
I got it here. Sorry.
Yep, something is happening. Now you should see a window popping up.
Okay. There you go.
Yep.
Okay.
Good.
Okay, so hopefully everybody can see my screen now. And let me go to my summary dashboard here. So as Aryan was talking about, this is the CloudPoint dashboard that we're looking at. This is a summary dashboard in which you get a quick view of your environment and what's going on in there. This is a slightly upgraded view from what Aryan had on his screenshots. What you see on your first panel is, all your snapshot jobs are working fine, and every job is passed. So that's the first screen, and you also see what clouds and arrays you have configured. So you will see all of the clouds and arrays are working fine as well. The second one is classification. As Aryan was pointing out, for GDPR, we are adding a component to identify PII. So it's driver's license, all of those other personality identifiable information in your snapshot. So you can say, what's going on? Do I need to keep this data? Do I need to delete the data? So you can take action on that data that is discovered. The third quick summary here is how many assets do we discover, and out of those, how many are you protecting on an ongoing basis? So it shows you, how many application disks and file systems you've discovered, and how do you are you protecting them or not? So that's a quick view. Let me go to the dashboard. This is our dashboard, and on dashboard, essentially you're talking about the same information on top, but now you get a more detailed dive into what else is going on in the environment. In CloudPoint, we split the assets that we see in environment into 4 broad categories. So the first category is applications. This covers all manner of applications from Oracle that is installed on your on-prem or your EC2 instances, and also RDS. So for example, I have my Aurora engine running here. I have an RDS, which is an underlying Oracle engine. I also have an Oracle, which we will come to in a bit, an Oracle database installed. So all of these are covered under applications. Hosts are those that are individual computing units. So anything like a EC2 instance, Azure VM, a physical machine, all of those are hosts. File systems, these are Linux and Windows file systems. We cover in Linux, for example, ext4s and XFS file system. On Windows, we have the Windows 2012 and 2016 and all of those NTFS file systems. Disks are any of those volumes or LUNs that you see on your on-prem or cloud environment. On your right, you have the administration console, and I'll give a quick view of this. This is the list of platforms that we support today, and configuring any of these platforms is as easy as entering your credentials for visibility. For example, if I have to configure Azure, then I just say add configuration and ask me for certain details. And if I enter those, I will discover all the hosts and disks in that Azure environment. So that's as easy as configuring that. So with the right network visibility, as Arden was pointing out, with the right network visibility, you can deploy CloudPoint in one location and be able to discover and manage all your assets from that one location. You do not have to deploy in multiple places. So this gives you a single point of control, visibility, and reporting. Then there are other policies. There is, you can define your own policies for retention and scheduling. This policy applies across all manners of assets that we discover. I'll come and show them how these work. And also have RBAC. RBAC, so you have, as part of RBAC, let's say you create a new role and you say asset manager. Asset manager, you can now select from a list of users who are available in your organization, give them permissions on what they can do as an asset manager. So they can probably do reports, they can manage your clouds and arrays, and they can probably do replication policy management. So choice of permission policies that are available, and you can select one or more of those. And on your third screen, you can also go to choosing what assets they are managing, and so you can assign those. So now when the user logs in, they get to see those permissions only. They get to do only those actions that are under the permission, as well as they get to see only those assets which are under that asset selected for them. And that can be one or more users. So you can select one or more users, and you can also change these available permissions on an ongoing basis. So in a sense, your role is mutable. It will grow and evolve as your organization grows and evolves. So that's one, role-based access control. Users, CloudPoint allows you to bring in users from different places. One is you can create your user on your own and let CloudPoint manage it. So CloudPoint manages through password and email and password. That's one way to do it. You can also bring in your Active Directory. So if you provide your Active Directory credentials, then CloudPoint can look into the Active Directory and authenticate against the Active Directory. So there you can bring your users from your Active Directory without having to manage them on your own separately as well. So that's a quick overview of what's going on in the dashboard. There are a bunch of one-time items hidden away from your from the preferences menu settings. Let me dive into Oracle protection, and I'll show how other pieces work. Let's go into Oracle protection quickly. So here's a Oracle instance that I discovered using CloudPoint. In this Oracle instance, what I'm going to show you here, this Oracle instance corresponds to the Oracle install that I have here. So this is my AWS console. In the AWS console, I have a few EC2 instances running. I have a couple of Oracle installs running over here, and then a couple of other machines that are going on. I'm focusing on Oracle 12c-3. So what it's showing you is I've installed essentially a single node Oracle 12c on EC2 using a Red Hat VM, and that is available on Oracle here. I've also configured an RDS instance, which has an underlying Oracle engine, and that is available here. So when I go to my RDS dashboard, I can see my Oracle instance with RDS. So it says, again, this is an Oracle Standard Edition 12, and it shows all your running characteristics. What I will do now is show you how to snapshot. Let's start with RDS protection, and then we will go to Oracle protection that we have installed on our own in the EC2 instance. So RDS instance is as simple as saying, identifying your RDS instance and saying create snapshot. So you say RDS snap demo, and this fires off a API call into AWS RDS, and it creates a snapshot in the RDS console itself. So let's see. Okay. So each time you ask for a new, new job or new task to be executed, you can see what's going on over here. And now that I've called for a RDS snapshot, this will be visible as well on my RDS console as well. So this is what RDS snap demo. This is my snapshot that is getting called. Once the snapshot is done, it will report back to CloudPoint UI, and we can see the snapshot available under the RDS here. So it would say one snapshot. Similarly, I have an Aurora engine which shows you all the 7 snapshots. So all your snapshots are available here. What's going on with your Aurora engine, and what is the level of protection, right? So let's wait for the RDS to come up. In a sense, we are using the RDS APIs, which limits our control on what we can do. So what you can do now is recover the entire instance from any point in time that you have taken a snapshot of. Now, I did a manual snapshot, so I went to RDS on my CloudPoint dashboard and said create snapshot. But obviously, that's not been the right way to do on a consistent and ongoing basis. What you now need to do is create a policy which will then do the snapshot for you on an ongoing basis for protection. So let's say we say gold app daily, right? So now I'm saying this is just descriptive name. I can choose any name I want. And then I say, the storage level that I'm looking at is application, because RDS as an application has a snapshot capability. And then I say an application consistent, and I'm saying I want to retain my RDS snapshots for maybe, I don't know, for 3 weeks, right? And then I say, okay, and those RDS snapshots have to occur daily at 2 o'clock in the morning. Or I could also go, I want to retain for 3 weeks, and I want to take a snapshot at 2 o'clock on Sunday. So 3 Sundays, and the 4th Sunday it will delete it. So I can choose one of these policies and have a combination of retention and scheduling. Once I save this, I just created a new policy. This policy can now be applied to your RDS engine that is running. So I'd say policies, and then I choose the policy that I want to apply to, and say assign selected, and just that. So now my policy engine starts executing, and every Sunday for 3 Sundays consecutively, it takes a snapshot at 2 o'clock in the morning, and that's creating your protection as a point in time. Now, I had earlier created some policies, which you can see over here. I had a snapshot job running otherwise for a 30-minute retention. So all your job logs are available here. You can look at what's going on in the environment. Now, we are calling the RDS API, which means we are reliant on AWS to supply the snapshot, and we are not adding any additional layer on top of that apart from the orchestration. So while AWS is doing the manual snapshot that I initiated, what I'll also show you is the I'll show you the Oracle snapshot that Oracle instance that I created. So here's my Oracle instance. I discovered the Oracle instance. I'll show you the discovery process in a bit, but here's my Oracle instance, and I've connected to Oracle instance using a SQL developer. I'm guessing most people on this call know SQL developer. That's a favorite tool for me when I try to connect to Oracle. Now, this Oracle instance is installed on EC2, which means there are some security issues on how we want to connect to Oracle. So what I've done to do that is first created a SSH host connection. So using this, I have I have a SSH host connection with a username and a key pair that is provided for the EC2 instance itself. So that's my PEM file. Now that in turn I'm using to drive the connection for my database. What I'm doing here is creating SSH tunneling, and that with the right credentials, it connects to my database on the Oracle side. What I'm going to do next is show you that we have a table. I've just created a simple table. A table. I'll delete a couple of rows from there, and then go back and use one of these snapshots which I created already. I have these snapshots, so they have the point in time from 7 o'clock in the morning my time. Now anything that I delete, I should be able to restore using this snapshot or any of these snapshots for that matter. So let's look at the current data that I have. So I have an employee table, and in the employee table I have like 6 rows. Maybe I can add a couple more here. And let's say a couple more here as well. Okay, and okay, so that I have now 8 rows in there. Now let's say I want to be sure that I get to protect all those 8 rows. I'm going to go to my Oracle and create a snapshot. So I'm going to say Oracle demo snap, and I'm going to choose a disk as my storage level. So what the difference between the host and the disk is, when you choose disk, we discover when you add Oracle, we discover all the structure or the tree of Oracle, where it is installed, where are the data files, where are the binaries, where are the log files, and all of that. So choosing disks exempts or excludes the root volume, in which hopefully you are not installing Oracle data files, right? All the data files are on the external volumes that we attached. So I'm going to choose disk and skip snapshotting the root disk as well. So just going to snapshot the data disks. And then I'm going to say application consistent, which is a signal. Sorry, just give me 1 second here. Sorry. Which is a signal saying that there is an application on top. So make sure that you take an application consistent snapshot, and then say save over here. So this fires a job for snapshotting my Oracle that I installed. Now remember, we are the flow of the Oracle snapshot is important, in which we are first putting Oracle in backup mode. Then we freeze the file system. Once you freeze the file system, we now take a EC2 snapshot, right? So we're essentially taking a storage level snapshot and not working on streaming the data off. It is a storage level snapshot, so it's dependent on the storage snapshot technology and not on the any sort of streaming backup as well as such. Okay, so this fires up a snapshot of the Oracle instance that is available. Now, as you can see, the RDS snapshot came back. So now if I go here and open up this, I see my RDS application available here, a snapshot available here. I look at snapshots. There you go. I just have a snapshot ready. And whenever I'm ready, I can, restore from this snapshot. I can say, go back to the original location. This is the RDS. I can say, go back to the original location, or I can choose a new location. When I choose a new location, it essentially opens up all the subnet groups for RDS available for that region. And I can, using the snapshot, I can, create under a new subnet the same RDS instance with the same data available, but it just restores the entire instance from there. So that's my RDS snapshot and restore. Let's go back and see how we are doing in the Oracle piece. Oh, there you go. So Oracle snapshot is created, the job completed. And then I look at this and see view snapshots. So this is my snapshot that I just created. Now I'm going to go, oh, I gotta close this. Sorry, give me a second here. So what I'm going to do is, using SQL Developer, I'm going to delete a couple of rows from the database table that I had. And this essentially just emulating corruption or an accidental deletion. And let's see how quickly we can recover from that failure. So now I have data here. So I have 8 rows. I'm just going to delete, whatever, some set of rows here, and then say that's it. So now I am back to 5 rows. I lost 3 data points over here. So I lost my data. So but I did a good thing, which is I had my snapshot ready, on an ongoing basis. So I select this snapshot and I say restore. Now what I'm trying to do here is bring back my data that I lost in my original instance. So I'm just supplying a restore job name, job 1, and say original locations. This will bring back my data to my existing database, and not have to dig through details of where it is and all of that. So let's say restore here. Okay, and that kicks off a restore job. What it is doing in the backend is it's now taking away the data or the disk, the volumes that are attached to Oracle, and initiating a volume level restore on the database that is there. So it is spinning up new volumes using the snapshots that it had taken earlier, attaching them to the Oracle that we store the metadata where the Oracle is, the Oracle binary is running, what the machine is, ID, and all of that. We attach it to that. We mount the disks. We we put Oracle back into running state. So all of that happens automatically without you having to do it manually. There are no manual steps involved in this process. Okay, this is going to take a couple of minutes to get going. While that is happening, I'm just going to walk you through the other pieces that's happening here. Now, remember when it started, we saw 0% protection, but because we have now applied a policy, a snapshot policy on an ongoing basis to one of the discovered applications, that protection level went up. Now, you ideally want to monitor this protection level so that that as and when assets come in, they are being protected correctly, and you're not at a data loss scenario. And that percentage level, it depends on your business SLAs. I would say anywhere 80, 90, 95%. That's an agreement that you need to come to with your app owners, but it would help you quickly monitor what's going on in your environment. Okay, this is going to take let's see. I should have shown you earlier here as well. So these snapshots are EC2 snapshots. So when I created a snapshot just now, you can see as in my EC2 dashboard, it created the snapshot of my disks, so at 841 and all that. And now it is restoring from those disks back to my Oracle instance that I was running earlier here. Right, so it's just going to take a few minutes to, oh, there you go, that's done. So now my Oracle is back up and running, and I can go to my SQL developer. I don't know why I keep closing that SQL developer. Okay, and if I spin up, hopefully, fingers crossed, I have my data back. Okay. There you go. So that's my live demo. I'm so happy this worked. So there you go. I have all my, sorry?
It's always a risk.
Yes, it is. It is. But I think our engineering team has done a fantastic job, phenomenal job of being able to do that. So essentially what we wanted to talk about here today is, no more, manual steps. Recovery is pretty fast. Remember, this is based on storage snapshots. So it is not dependent on the data that you have. It is, it's really dependent on just the size of the volume that you are spinning up and spinning down. So there is no, even if you have a large database, essentially the time doesn't increase by any significant amount. You would see quick recoveries, quick snapshots, and quick recoveries on an ongoing basis.
Well, that's interesting.
Yeah, it is a storage snapshot, right? It is not, we are not moving data, so you would have very minimal downtime from that perspective.
So is it conceivable that it's actually faster than a regular restore if the data is really data size is really large? Is that even possible?
Yeah, it is. So that is the whole premise of snapshot based technology, which is you are what we have found in our testing is it slightly depends on the platform. For example, AWS versus Azure versus Google Cloud or one of the arrays. It depends on the performance of that underlying storage itself. But beyond that, you would have, if you compare one storage platform and compare this technology versus a streaming based backup, this is way faster than anything that you can do with streaming.
Because the streaming has to basically rerun the whole thing, the whole insert update statement.
Correct. So I think I'll pause and I'll try not to do anything more for the demo. I think that was all that I had, unless there's some questions and I can dig into more details.
There are a few questions, and everyone, please feel free. I see a number of questions already coming in, but please feel free to enter your questions. So let me start from the beginning. This is more like Patrick asked a question, but this is probably not the product related, because this was asked before you did the demo, but I like to ask it anyway. Does the customer have access to a database in the backup mode? And when you go to the backup mode in an Oracle database, does the customer have access to the database in read-only mode, or how does that work? Patrick asks.
So if I understand that correctly, are you saying can the customer continue doing the transactions while the backup is happening?
Yeah, I think that's the question, because I'm not familiar with the backup mode. I'm not a DBA, but once you put the Oracle database in backup mode,
right. So
people can still use the database, right?
Yeah. I did not have to shut down the database or anything. It just goes into Oracle backup mode. It takes a few seconds to take the. Remember, in AWS and for that matter, any cloud provider, you call a snapshot. It takes a couple of seconds to put that marker, and that's it. And then the snapshot is done. It will take care of being consistent and everything in kind of an offline manner, and we can get back to our primary Oracle operation without doing anything. So there will be a couple of seconds in which your transactions are going to pile up, your archive, your logs are going to pile up, but that's about it. Beyond that, the snapshot is happening on its own in a separate, sort of a container, if you will, whatever AWS does, and you can go back to working on your primary. There is no, pause as such.
Mm-hmm. Arun asks, well, you'll have to help me to decipher the question, but could you please explain again the disk and host difference?
Sure. So we recommend that when you install, and I'm guessing this is standard practice, which is when you install Oracle, your Oracle binary is on the root volume, or even for that matter, any separate volume. And your data disks, so when I say data disks, that is archives, redo logs, all the buffers, these are on separate disks or volumes by themselves, right? They're not on the root volume. So if I look at my configuration here, here's my Oracle configuration, Oracle EC2 instance, and I have, SDA1, SDC, and SDB. So what I'm saying is my Oracle binary lives in SDA1, but my data disks and my app data and all of that lives in SDB and SDC. So when I call a host snapshot, I will snapshot all three, but I need to protect my data. I don't need to protect my binary. I can bring in a binary anytime. So what I'm recommending is you just protect your disks where the data is, and that saves you some like a third in this case. It saves you a third of your storage space and your snapshot space costs. So you want to avoid that cost. If you want to go full thing and snapshot the whole host, sure, you can do that as well.
Next question.
So that,
the next. I'm sorry. Are you going to say something, Aryan?
yeah, so I was just thinking maybe some people confuse host level snapshot with maybe application consistent snapshot. Is that correct, Shishintya? I think.
Oh, so okay. So to that, it doesn't matter what level you are taking the snapshot at, like disk or host. We will still take an application consistent snapshot. We will maintain the application consistency. It's just question of how much storage space or what is the level of recovery you want. If you want us to, that is a good another point, which is if you want us to bring back your binary as well, then you need to take a host level snapshot. But if you are happy to do the binary and we just bring back the data, then just disks are fine. Either way works for us. I think the question is, and we will be application consistent on both ways, but it's a question of how much storage space do you want to use on your snapshot?
Yeah, the questions keep coming in. So Kausal Yadevi has a question. How does this work when there are multiple tables? Can I choose only a table level restore?
Oh no, yeah, this is a full database restore. In fact, we are building towards a more like a pick and choose. You want to just restore this piece or that piece from there. Right now, I restored the whole thing, but we are getting to a point where you can pick and choose what you want to restore.
Well, his second question is how big are the snapshots in size? But I guess that depends on how big your data is or storage value.
Yeah,
it depends also on the AWS platform. So you will have incremental snapshots. So the size will depends on the changes since the last snapshot.
Next question is, and I got this from multiple people. What's the difference between Flashback technology, Oracle's Flashback technology, and this product?
I do not know enough to answer that question correctly. From the sounds of it, I would say no. I honestly, I don't have enough insight in that. I haven't looked into it.
From what I can tell, Flashback is just basically you can tell Oracle, bring me the data exactly from this date and time. Run this query, but as if it's last week. So there are things you can do with the Flashback technology, but Flashback is not backup and it's not recovery. It's just, it allows you to query things in the past as if the database hasn't changed. It's not backup, it's not recovery. It's a different product. Also, the other difference is that this product works also with non-Oracle products. Well, first of all, they're not the same thing at all. One is a backup and recovery product. The other is just, helps you do historical queries. So there isn't really a similarity at all. Even though the thing is, I think what confused people is that, the example was only for one table, and then people are like, oh, I can just do Flashback. But, it's not just one table, but the whole database you need to recover. No, that's not going to be Flashback. And if your database is gone, your Flashback is also gone because, you lost your database. So it's not the same thing at all. So Arun's question is, I think I asked that, but is this snapshot restore faster than normal restore?
By several times. It is faster by several times.
When normal restore will be in streaming backup solution, you mean?
Yeah. Well, yeah, there are different ways. It's not my area. So Christoph's question is, how do you manage recover point in time? How is recover point in time managed if you have to recover to a precise time?
So that's dependent on when you took the snapshot. So if for example, I'm looking at my screen right now, and I have Oracle configured. I should have talked about Oracle configuration as well, but that's easy. I have Oracle configured, and my choices for recovery point in time is based on when I took the snapshot. So if you look at the snapshots of the Oracle application, you see the times associated with that. So when I've had earlier configured a policy, it was configured to run every 30 minutes. So every 30 minutes, you can go back in time every 30 minutes and recover from there. So it's really dependent on when your snapshot happened. It's a point in time. You cannot apply a redo log or transaction log for that matter.
Next question, Mohammed asks, were you using ASM or Veritas file system values?
This is ASM. This is on a where is that? This is on a Red Hat Linux machine. It doesn't use any. When we deploy the code, we are not using any other technology. We are just using your environment. So the Red Hat Linux VM, Oracle installed by you, and we just deploy the code to put Oracle in backup mode and do all the nice stuff to make it application consistent. That's it.
Patrick's question is, when I want to restore a snapshot table, would it be best to restore the snapshot in a different location than the master source?
Yeah, so we can replicate to another region. So if you look at how EBS snapshots are done in AWS, it will be stored in S3, although it stays invisible. So if you go to your S3 bucket, you won't find any snapshots. But Amazon, what I understand, is storing it in the S3 platform. That automatically then at least will be replicated to another availability zone within that same region. But if you would like to have more resiliency by moving it out of the region into another region, we can do that with replication, which you can easily configure within a policy. Maybe you can show that, Sushintya, how to do that.
Yeah. I'm just going to open up replication. So there are a couple of things, steps there. One is do a quick replication rule, which will show you, okay, what is your source region. So if I say US East 1 is my source region, and my destination is US East 2, which is US East 1 is Northern Virginia, and US East 2 is Ohio. So that's my source and destination. I can choose 2 more, but I'm just going to leave it at this. Or maybe I can select 1 more. That's okay. US West 2 as well, and then say save. So that creates my replication rule. Now I can, say for example, I go to a host, pick a snapshot, view snapshot, and then I say replicate. So now, this is based on manual snapshot, but you can also apply that to a policy. Let me go to a policy here, replicate, for example, and then check replication over here, enable replication. So now in this policy, any host that is getting snapshotted, which comes from one of those 2 regions, for example, US East 1, it will realize that that asset is in US East 1. It is being asked to be replicated. So once a snapshot is created in US East 1, that snapshot gets replicated to US East 2 as a destination. So that's all that's there to it. I mean, it's all automated. You don't need to do anything. If you want to do it on your own, then you can, go and pick a snapshot and replicate as well.
And a final question Mohammed has, and again, this is something we talked about, but I think many people want to clarify this. Using this snapshot method, restore is always full database and not at a table space or data file level, right? That's the question. I think that's what people want to clarify.
Correct. Yes, today it is that we are building towards the other requirement, which is being able to pick and choose what databases or table spaces that you want to recover.
That's cool. Apparently, there is a need for that, because I received this question more than once. So
yeah, we can probably do a preview again in a couple of months, but yeah,
why not?
Yeah.
Amin asks, is CloudPoint using its own means, Veritas Snapshot technology, or native?
It is all native snapshots. It is using EC2 snapshot technology.
Yeah, it's all native. So that's what I understood too. I mean, it doesn't matter what the file system is, what you're working with. Because Veritas has a file system, and that people are worried that it's used. CloudPoint is only working with the Veritas.
No.
I didn't know you had a file system.
Oh, we are very good with file system, but we are not using that.
Okay. Some side effects of having a good file system, I guess.
Yeah.
Well, I guess that's it then. No more questions. Anything else you want to add to Cynthia or Arjan?
Yeah, I just want to show a couple of more slides before we can wrap up. Is that okay?
Yeah, of course. Yes.
The control.
I can give you the control, I guess. Hang on.
Cool.
Make presenter. Okay, I just made you presenter. I take myself out of it.
Cool. I think everybody should be able to see now my screen. Oh, yeah, here we are. So what Sucintya basically showed you during his demo, we discovered the Oracle assets. We showed you how to kind of create a policy, schedule some of the snapshot jobs, making us application consistent snapshot of the RDS instance, DBA instance, and as well as the Oracle database on EC2. And also restore that again. So, and also we looked at replication to another region. So, if you may ask yourself, okay, how can I get started? Now we make it very easy to get started. So what you can do is download the freemium software from our .com page, which is veritas.com/CloudPoint as one word. There you can download the software for free, and you can use that in your production environment as long as you want. And it's really good to evaluate your solution, kind of proof of concept, and also to getting you started in the cloud. But yeah, if you need more features like the application consistency or phone support, then you can kind of upgrade to a subscription tier, which is an Express or the Enterprise. The Enterprise will include all the features that goes from what I mentioned, application consistency, replication, granular recovery, PII, all those advanced features. So yeah, I think with Veritas CloudPoint, it really is using the native capabilities, what we already talked about, of the cloud platform, so the snapshotting capabilities, but it is adding all those additional features that you need to make your job as an data DBA, but also as a backup administrator easier. So we have the RBAC, we have the scheduling capabilities, the automation capabilities, and discovery capabilities. All that is added kind of to the native things that you can do in the cloud, and you can use that CloudPoint as from one location. So, for example, now we run it out of the AWS cloud, but it's very easily also to include an Azure cloud or a Google cloud and manage everything centrally, which is kind of a key advantage. So yeah, I really would like to encourage you to download it from our veritas.com site /CloudPoint. I think we already went through a couple of questions. So I think I'm not sure if you still need this slide, but yeah, if there are any more questions, Yaliam, just let us know and we can get it answered.
Yeah. No, I think we're good. Nothing so far. So I think it's time to wrap up. Aryan, Suchintia, thank you very much. And everyone, please take a look at Veritas Solution. Seems like a good way to get rid of this problem and solve this problem. Love the UI, by the way. I love the new UI. I know you guys were working hard on it and looking forward to it. Very nice, very intuitive. So everyone, please take a look and download it. It's a free trial. I think it's definitely worth a look. And again, thanks so much to everyone for their time. And we'll see you in the upcoming webinar next month. If a few people asked if they're going to receive the webinar recording and the slides, and yes, I'll send everyone who registered the recording of the webinar and the slides in the next few days. Again, thank you very much, and we'll see you in the next webinar.
Thank you, Alan, for the opportunity. Thank you. Bye.
Thank you.